All right, so let's say that we have 100 students sit a maths exam. We've got the scores given below in the table. We know how to summarize this data, so we know how to calculate the mean and the standard deviation. And we can also look at the distribution of scores. So imagine we have buckets or bins that we put each person into. So for example, let's say 3 people got scores between 55 and 60. One person got a score of 56, another got 57, and another got 59. If our range of values in that bucket was 55 to 59, we would have 3 values in that bucket. So we can see here that we've got 3 values in that bucket, 10 in this one, 11, 23, 22, and so on. And by plotting the frequency of scores in each bucket, we create what's called a histogram. So that's just a way of visually displaying quantitative information. And what that does is it allows us to see the distribution or the pattern as to how these scores fall. So we can see that it has a certain shape to it. More people get scores closer to the mean, as we might expect, and less people get scores further away from the mean. So we say that the distribution looks roughly symmetric, and we can overlay a bell curve, which looks a bit like a bell, which we say indicates a normal distribution. Normal distribution is a very, very common distribution in statistics, and it models a lot of real life data, such as height, weight, salaries, happiness, etc. We think most people have a similar height. The frequency of very short people or very tall people is going to be a lot less than people who are around the average height. So it just represents how values are distributed around a mean, with most values falling close to the mean, fewer values appearing as we move further away. And it's only defined by 2 parameters, the mean, which is our average, and the standard deviation, which measures the spread of our data. And we say that the area underneath the curve represents the probability of an interval. And since probability always sums up to 1, we say the total area under the curve adds up to 1. So if we focus on the range less than the mean, so everything to the left of the mean, that represents the left half. So that would account for 50% of the data, and the same as if we were looking at the right of the mean. So we say that the probability for that range is 50% or 0.5. And if we look in this graph here, we can see that the purple shaded area represents 50% of the data, and the mean occurs at the peak of that curve. So given the mean and standard deviation of the data, can we work out the probability of certain ranges occurring? So for example, given a mean of 75 and a standard deviation of 10, what's the probability someone got a score of at most 85, so 85 or lower? What we want to do is work out the area represented by the purple shading up to that dashed line, which represents our 85. And the way we do that is we convert it into standard deviation units. So we want to work out how far is 85 from the mean of 75, but in terms of standard deviation units. So the first thing we do is subtract the score away from the mean. So we do 85 minus 75, and we can see that it's 10 units higher than the mean. And we also know that one standard deviation is 10 units. So if it's 10 units higher and one standard deviation is 10 units, it's just one standard deviation away from the mean. If a standard deviation was 5, for example, then 10 units would be 2 standard deviations. So the formula for that is Z equals the score minus the mean, first up, and then divided by the standard deviation, and that gives us our Z score, which we say is our standardized score. So we've standardized the data, and we now call this the standard normal distribution, and that's always centered at 0 and has a standard deviation of 1. And this makes it easy to get the probability. We can either use Z tables, we can use Excel, we can use an online calculator, and we just plug in what's the probability X is less than 85, which is equivalent to now saying what's the probability z is less than 1? So we're less than 1 standard deviation from the mean. And if we use either one of those tools, we'll get 0.8413, so around 84%, which indicates that the probability of getting a mark of at most 85 is around 84%. What if we wanted to go the other way? What if we wanted to work out what score would put someone in the lowest 5% of scores, to the bottom 5%? In this case, we know the area, and we know that's 5%, or 0.05, but we don't know what that z-score is. But we can use the same z-tables, or online calculator, or Excel, that we used before to get a z-score that corresponds to an area of 0.05. So in our calculator, we'll plug in the area this time, 0.05, and then that will in turn give us a z-score, and in this case, that will give us a z-score of negative 1.64. Why is it negative? Because if we're in the bottom portion, so the bottom 5%, we're on the left of the mean, we're on the left of that 0, so we're now in negative territory, and we get negative 1.64. Given that we've got z, we can now go backwards and work out what we say our raw score was, so our x was. So we know z's negative 1.64. We know the mean 75. We know the standard deviation is 10. We can just take that formula, rearrange it, solve for x, and we get 58.6. So a score of 58.6 or lower would put someone in the bottom 5%. And that is z-scores going forwards, going backwards, and also getting the probabilities as well.